Welcome to qnawire.
So in this section, we've been using Stokes' theorem as a really helpful tool to simplify the integrals that we're dealing with, specifically surface integrals. So Stokes' theorem tells us this right here, where C is the boundary of a surface oriented counterclockwise, and we have the freedom to choose the surface whose boundary is C. So we have S being the region inside the rectangle formed by the given points. We are given F to be the vector z squared, 2xy, 4y squared. So that means that the curl of F will be equal to the partial derivative of y with respect, or the partial derivative of r with respect to y. So that will be 8y minus the partial derivative of q with respect to z. And then looking at the curl formula, we get that this will be 2z minus 0, and then 2y minus 0. So the curl of F is equal to the vector 8y, 2z, 2y. And then we want to find the equation of the plane passing through the four given points. So we let the equation of the plane we know to be ax plus by plus cz equals d. And the point 1, 0, 0 on the plane indicates that a equals d. The point 1, 2, 1 indicates that a plus 2b plus c equals d. And then the point 0, 2, 1 indicates that 2b plus c equals d. So if we subtract equation a from equation 2, we see that a is equal to 0. And that implies that d is also equal to 0. So just by doing that simple but yet clever algebraic manipulation, we can change our equation of the plane to be much simpler. So it'll be by plus cz equals 0 because both a and d are equal to 0. Then we can use equation 3 to replace c with the negative 2b. So we'll get minus 2bz equals 0. So that tells us that y is going to be equal to, or z is going to be equal to y over 2. That's because we can move this over and then divide by 2b. Now that we have that, we can go back to our formula. And what we're going to be using is, what we're going to have now is the double integral of negative 8y times 0. And this 0 is coming from the partial derivative of g with respect to x. And g in this case is z equals y over 2. So because there's no x involved, that means the partial derivative is 0, which means we can just get rid of that. Minus 2z times 1/2, because that's the partial derivative of g with respect to y. And then lastly, we add z, so that'll be, or we add r. And in this case, r is going to be 2y. This will be dA. And this will simplify to a negative z plus 2y dA. Then, since z equals y over 2, we can do that here. And simplifying things further, what we'll end up getting is 3 over 2y. So we'll just be left with y inside and 3 over 2 on the outside. And with all that, we see that the bounds of integration, this will be dy dx. We know the bounds of integration are going to be for y from 0 to 2, because that's what the rectangle looks like. And then this will be 0 to 1. It shows us that we have the amount of work done will be 3 units, depending on what units we're in. And that is as a result of what we can do with Stokes' theorem.